Good morning, good afternoon, good evening. Thank you for joining us today. I'm Miguel Mendez, marketing specialist here at Unravel Data. And before we get started, there are three housekeeping reminders that I would like to cover. The first is, throughout the webinar, please drop your questions into the question box, and we'll do our best to answer them live or respond via email if we're short on time. If you submit one of the top 10 questions during this event as ranked by one of our fantastic panelists, you'll earn some cool Unravel swag. Additionally, this webinar will be available instantly on demand to listen to at your leisure, so feel free to pause or replay as needed. And lastly, help us improve. Share your feedback on the session by rating this webinar, and let us know if there are any other topics you'd like to hear about. All right, that covers it. So with the reminders out of the way, the floor is all yours.
Thank you. Hi, my name is Clinton Ford, VP of Product Marketing at Unravel, and I am joined today by Eric Chu, VP of Product at Unravel. Today, we're going to discuss data observability and FinOps for high-volume users of Snowflake, and we will show you how you can accelerate time to value with AI that is purpose-built for Snowflake. So here's a look at our agenda. We'll start by taking a look at some of the top challenges to optimizing performance for data analytics and AI. Next, we will review the options for data observability and FinOps. Then I'll share an overview of Unravel. At that point, I will hand it over to Eric Chu to share a demo of Unravel for Snowflake. And next, we'll answer some of your questions and then share how you can get started. So Kumar Menon is the Chief Technology Officer for Data Mesh and Decision-Making Technologies at Equifax, a global data analytics and technology company operating in 24 countries globally and serving customers across a variety of different industries. So he and his team needed to deliver capabilities to enable real-time decision-making, but they faced a number of challenges. Equifax is in the real-time business. The organization depends on the ability to bring unique data assets together to enable real-time decision-making. This requires seamless and rapid processing of large volumes of data. Achieving low latency decisioning for scenarios such as sub-second credit scoring while ensuring accuracy and reliability is a significant technical challenge. Equifax needed to significantly improve the ability to analyze and integrate new data domains across 6 cloud regions. It required them to engineer observability into the ecosystem to understand how the system works. Equifax manages over 10 petabytes of data online to be able to serve their products. Ensuring scalability and performance of their cloud infrastructure is critical. Optimizing resources to handle peak workloads efficiently without slowing performance or response times. Equifax needs to ensure reliable data operations to support over 12 million online inquiries per day. They have extremely stringent SLAs. Imagine that you are one of their customers, like a bank, and you're interacting with the bank online trying to procure a credit product, and you're querying Equifax in real time and retrieving a credit score and decision. And that requires Equifax to reliably deliver responses. Equifax ingests over 15 billion observations per day from millions of sources globally across various industries. Unifying diverse data sets into a single ecosystem while ensuring performance, reliability, and efficiency poses a substantial challenge. This involves integrating data from many sources, cleansing it, performing entity resolution, and maintaining data integrity throughout the process. So data observability and FinOps help to optimize performance, productivity, and cost efficiency. And I'm excited to share a new analyst brief written by Nancy Goring, IDC Research Director of Enterprise System Management, Observability, and AI Ops Software. And this brief provides context for business leaders. For example, in this brief, you'll see the key aspects of data observability and highlight the role of data observability in enabling AI-driven applications and services. So companies who buy Unravel often start with homegrown tools developed in-house and based on open source software. But these are difficult to use and require a skilled team. As they experience the need for more regular and consistent reporting, they frequently turn to built-in tooling and instrumentation from cloud service and cloud data platform providers. But these tools often lack the granularity needed for data platform showback, chargeback. Then, as their data usage rapidly expands, they turn to third-party generalist tools, but these generally lack full data stack visibility. And as the data platform grows to support data and AI pipelines and applications, they tend to adopt purpose-built data observability tools to enable productivity, performance, and cost efficiency. An ideal data observability and FinOps solution enables data teams to achieve performance, reliability, and be more productive. Using these capabilities, you can improve performance, productivity, and reliability to achieve your goals. So Unravel is the only AI-powered data observability and FinOps platform that lets you shift left, enabling self-service for your entire team, enable everyone, experts and non-experts, to be more productive, optimize the performance of your data and AI pipelines, and gain visibility into the costs and help ensure cost efficiency. So on the left is a visual that shows your cloud data analytics platform. Unravel looks at the telemetry from that system and uses the AI Insights engine to generate these self-service data ops views out of the box, and then provides recommendations to improve performance, to improve productivity, and to enable FinOps chargeback and showback reporting. With CI/CD integration, developers can see an automated review of their code before it ever goes into production, and the team can be alerted with automation and respond quickly with guardrails that are built in. So over the past 5 years, Kumar and the Equifax team set out on a journey to really revamp their technology ecosystem and move to a cloud-native architecture. And they've engineered, data observability and FinOps into the ecosystem to understand how the system works and also to deliver their real-time and batch products to their customers. And they found it very useful in this entire process to provide self-service to the teams who are innovating. This helps them understand the performance and cost of their data products. And this has accelerated data product innovation and delivery. So Unravel is the most proven data observability and FinOps platform. We're a FinOps Foundation member, named Best Data Tool and Platform of 2023 as part of the annual Cody Awards, named to the Big Data 100 list for the 5th consecutive year, and among the inaugural group of the coolest data observability companies of 2023. A finalist in InfoWorld's Technology of the Year Awards for Cloud Cost Management, and named by Gartner as a sample vendor for both data observability and augmented FinOps. So now it's my pleasure to introduce you to Eric Chu, VP of Product at Unravel, for a demo of Unravel for Snowflake. Thank you, Eric.
Thank you, Clinton. Hello, everyone. I'm Eric. Today, I'm going to give you a demo on our health check feature for Snowflake. Let me share my screen. The Unravel health check gives you an overview of your usage, the inefficiencies for cost and performance, recommendations to address these inefficiencies, and the potential cost savings and performance improvement if you apply these recommendations. The report also shows you the result of our out-of-the-box alerting on common use cases and the tracking of your progress in applying these recommendations. So let us take a look at these features in more detail. Once you've connected your Snowflake account to Unravel, Unravel will automatically analyze your workload and generate a health check report once a day. The report will be based on the workload over the past 7 or 14 days, depending on your configuration. At the top of the report, we'll show you an overview of your usage, starting with the total cost and its breakdown into the compute, storage, and data transfer components over this period. We also show you the annualized cost projected from this period. For the usage in compute and storage, we show you the number of warehouses, queries, tables, and the size of these tables, as well as the number of users that have been active for these Snowflake accounts that you have connected to Unravel. If you have connected multiple accounts to Unravel, then this health check report will show you the aggregate findings across all these accounts. Next, the report will show you the potential improvement that Unravel can give you as a summary. So these potential improvements come in 3 areas. The first one is increasing productivity. a main factor in increasing productivity is to reduce the time to discover problems. Unravel helps you on that area by automatically analyzing the workload and identifying insights and recommendations for your warehouses, queries, and tables. So here we show you the number and the percentage of warehouses, queries, and tables that have insights and recommendation. The next way that Unravel improves your productivity is CI/CD integration, which I'll go into detail later in the demo. But in short, CI/CD integration allows your developers to see Unravel recommendations in their pull request directly in the form of review comments, so that these developers don't even have to go to Unravel to learn about the inefficiencies. And they can address these inefficiencies by following the recommendations before merging their code to production. So this is a very good way, effective way of avoiding bad code to be merged into production. And here we show you the number of insights, the number of requests that Unravel has added insights to. On the right, we show you the number of observed instances from our out-of-the-box alerts for cost and performance. But Unravel actually supports both out-of-the-box and custom alerts. So here, right after you deploy Unravel, you can already see the observed instances from our out-of-the-box alerts, and you can, of course, configure that or create your custom alerts. The second area that we help you with is reducing cost wastage. And Snowflake pricing is based on compute, storage, and data transfer. In practice, the bulk of your costs will come from compute. Roughly 80 to 90% of the cost will come from compute, and then about 10 to 20% of cost will come from storage. That's what we observe the most common observation. So our insights to reduce cost wastage also focus on these areas. On the compute side, the bulk of the cost is coming from warehouse, and we would tell you the warehouse recommendations. The warehouse cost is a function of the size of the warehouse and the duration and maybe the settings of the min and max clusters that are for your auto scaling, as well as the auto suspend setting that determines how soon the Snowflake would suspend your warehouse automatically due to inactivity. So we have recommendations for all that. And here we show you a summary of the aggregate savings per year that you can achieve. And what is the percentage of that savings out of the total warehouse cost. Next, we have the table insights that also lead to savings. And here is an aggregate of those savings per year and the percentage of that savings out of the storage cost for the year. Queries are the workload that run on these warehouses. So technically, they don't get charged separately. You only pay for the warehouse and the warehouse cost. But it is important to optimize these queries because inefficient queries mean larger than necessary warehouses. And without optimizing the queries first, if you just downsize the warehouse, then you can risk worsening your query performance. And to motivate people to optimize their queries or to make them more aware of the impact of these queries, we have provided estimated query level cost for each query. And when we provide recommendations for query at the query level, we also provide expected savings for that recommendation. So here we have aggregated all those estimated savings at the query level, and then show the percentage of this savings out of the annualized query level cost. On the right, you'll see the area that we also improve, which is improving performance. And here, performance is defined differently based on what we're talking about. For warehouse, the performance improvement is defined by utilization improvement. And so we show you the percentage of warehouses that would benefit from our recommendations and what is the average improved utilization. For queries, we show you the percentage of queries that would benefit from our insights in the performance improvement category. And the performance improvement here is defined by the duration. So we show you what is the average duration improvement across all these queries. Now, after this summary, we'll start digging into deeper the insights for each of these categories. Let's start with warehouses. So warehouse, like I said, there are different configurations that we could tune. And the problem that we are looking to mitigate, to improve, is underutilization, which is where a warehouse is too large for the workload. The workloads running on this warehouse actually don't need all the resources available. So we can downsize the warehouse without having a huge impact on the query performance. So what we have shown you is the list of warehouses that can benefit and the aggregated wasted cost over the 7 days that we have observed, and an annualized savings to show you how much you can save per year if you have applied these recommendations. There are two types of recommendations for this problem. One is right-sizing individual warehouses. So let us take a look at that. Here we show you the list of warehouses where you can right-size individually. And if you click on that, you'll see that our recommendation actually is provides you a weekly schedule down to the hourly slot of which size you should use. This is generated based on analyzing your warehouse workload over the past 4 weeks, and then applied our machine learning algorithm to predict what is the expected workload, so that the recommended size that we provide here is the one that fits the expected workload. And we will change the workload based on the different times, so it accounts for peak hour workload versus non-peak hour. So all these recommended settings are shown here in green, side by side next to the gray area for each day, where the gray one is showing is the current configuration. If you decide to apply the recommendation, you can do so easily by clicking on the Apply Recommendation button and confirm your choice. Then the recommendation will be sent to Snowflake and executed at the right time. You can see the actual code doing that over here, and even copying it, and so that you could override some of the selections or customize it the way you want, and then run it on Snowflake. The second approach to address underutilization is by combining multiple underutilized warehouses into one. So that's consolidating warehouses. And here we show you the list of recommendations we have. And for each recommendation, we will tell you the list of warehouses that can be combined into one, and the size that you should use. Note that this recommendation is based purely on analyzing the workload and the utilization. In this current version, it does not consider business reasons. And the plan is that in the future, we would allow users to specify options, filters, such as, I only want to consider warehouses to be consolidated if all of the warehouses belong to the same business group expressed by tags, or belong to the same owner. So that's coming very soon. The other insight that you see is the recommendation on the min and max cluster for a given warehouse. So this event actually has an impact on both cost and speed up. We adjust the min cluster based on from a savings concern, whereas for the max, we're addressing it for a speed up concern. So based on the workload we observe, we may increase or decrease the speed up. So we have both estimated benefits here. The two other types of insights that we're not showing, but we actually support. One is moving queries to a larger warehouse, and the second one is moving queries to a smaller warehouse. So those insights are suitable if your warehouse has different types of workloads that have different resource demands, and often you want to move one type of workloads to a different warehouse so that the remaining workload is more homogeneous and it allows you to right size to right size or upsize to the right size more easily. And so the examples are not shown here, but we actually do support that. So you see the list of queries for a given warehouse that can be moved to another warehouse of a different size, either a larger size for better performance, but that will actually that could increase the cost. So and then the second type is moving the queries to a smaller warehouse, which will lead to lower cost. Next, let's take a look at the queries. And here we are showing you two different types of queries that we are considering. One is inefficient queries. So those execute successfully, but are either too slow or too expensive. Often that's, if one is true, the other is also true. And here we show you the different types of query inefficiencies, like single row insert, as opposed to a bulk insert. And then projection inefficiency is about select too many columns, so that leads to unnecessary large scans. SQL anti-patterns is various bad practices and pitfalls of writing SQL queries. Sometimes they are justified, sometimes they're not. And so we want to get the attention of the developers to confirm that they are either done by design or they have a chance to correct them. So if you click on this, for example, then you'll see you will get redirected to our queries page, and you'll see all the insights in that category being shown. And since we're here, I'm just going to click on some of the insights that are interesting and show them to you to illustrate the idea. So here you can see in this query detail page, we show you the whole query text, as well as the headers with KPIs, etc., and metrics and tables that they touch. But most importantly, most usefully, people come in for the insight. And here we show you that this particular insight is telling you that a rank function is being used to get just the top record. And that is an inefficient use of rank function. You can actually achieve the same result by using a max function instead. So we would even provide examples for how you would rewrite such a query. Another example would be using functions in a predicate, which would slow down the query significantly. And sometimes this may be intended, right? You do have to do that, but often people don't know or they don't think about it. So we would catch all these and allow the users to review them. And these are also the same insights that you would be able to see in the CI/CD integration that I mentioned earlier. Coming back to the homepage and continuing our journey, the next category is the join inefficiencies, which is about like slow and costly joins, or maybe even just Cartesian products. And here we will show you what are the top K most frequent unique queries. And what is the percentage of these queries out of all the inefficient queries? Because often a few unique queries may be responsible for the bulk of the inefficiencies. So we want to call that out if that's the case. Next, you can see that we show you the analyzed savings by applying these recommendations, as well as the improvement in performance. On the right, you see we show you the top expensive unique queries so that you can click into it and then see saw all the different runs and the insights that we have shown for that query template. And here you can also see the number of runs, so that the more runs, usually that means the query is more, the unique query is more impactful. And we show you the estimated cost. The next category is the failed and timed out queries. In Snowflake, actually, a query rarely fails. If it fails because of syntax error, like those will, the query won't even run. The queries that run for a long time and then that don't execute successfully in the end usually are timed out queries, where they take a lot of resources and a lot of time to run, and eventually they hit the threshold for how long a query can run. So we show you all of those instances and how many unique queries are responsible for those, as well as the cost wastage as a result of running these queries that don't produce anything, but they incur cost. Then we project the annual cost and tell you that, hey, if you address these or you don't run them again, or new query based on the projection, such new queries may come up in different months. So we'll give you an annualized estimate on the savings due to timed out queries. Now, to solve that, you have to troubleshoot. So here we redirect you to queries that have insights that may optimize and make it run more efficiently. Or in the end, maybe you simply have to move queries to a larger warehouse. So both cases are here, and you can click on the links to redirect and see all the queries that have this problem. On the data side, we keep track of tables that are incurring costs but have not been used recently. So the out-of-the-box definition is tables that were created for more than 60 days and were used more than 60 days ago, read more than 60, or write more than 60 days ago. So these are the aggregated wasted cost of all these tables from the past 7 days. And to help you understand the impact, we would tell you the annualized value of that. And if you delete them, then you could save this amount of cost for the whole year. So the recommendation is to consider deleting all these code tables, and clicking on this link will lead you to seeing the list of all these code tables. The definition of the code tables can be adjusted, and you can go to our data page to do that. The next insight is about significant size changes. And this is not about cost or performance, but more about data quality and reliability. So when the tables, we track the size of the table every day. And if the size has some anomalous change, then we want to flag it, because usually it indicates something is wrong in the data pipeline. Maybe you have redundant data, maybe you have the pipeline is very late, so you have missing data. So all that will impact downstream queries that read from this table. So we would raise these events, and we will show you how many of such tables do we detect over the last 7 days, and the number of queries that read from these tables. And if you click on this link, you'll be able to see these tables with this problem. And you can also see the queries that write to these tables. So those are the data pipelines populating the tables, and the queries that read from these tables, which means the queries impacted by this problem, potentially. The next tab, we have operations. And earlier I mentioned we support both out-of-the-box and custom alerts. Here in the health track, we show you all the out-of-the-box alerts that we do. For example, queries that were canceled, but so they don't produce any results, but they were expensive. They cost more than $100. And then next we have the running queries that had failed before in the last 7 days. So the chance of them failing again is very high. So we want to alert that. Then we have queries that ran longer than 80% of the warehouse level timeout. So they are probably going to time out soon. Then we also have queries that ran longer than 10 minutes, as well as queries that costed more than $100. All of these thresholds can be adjusted, and we have help for you to decide on what are the right thresholds that you should use. And the enabled and disabled state here indicate whether or not the alert is turned on. By default, they are disabled. And you can enable them so that you get a notification in your Slack or email or Teams, etc. But even if you have not enabled these alerts so that they are disabled, you will still be able to come into this health track report and look at how many instances have we observed that violate this condition. So maybe you don't want to turn on the alerts at the beginning, but you can still come in and check out the statuses. Below that, we have CI/CD integration, and here is an example of GitHub. Though we do support CI/CD integration with other environments such as SonarQube, GitLab, etc. So this is an easy process to connect Unravel to your GitHub environment. You just need a token. And then after that, your developers will, when they create PRs for their code, they could immediately see Unravel insights about that pull request. That could be based on you have run some previous run that you have pasted in the pull request, so that we know we can retrieve the insights about those past runs and show them to you. And you can also just, without any previous run, post your code here, and we will do what we can with the information we have. So if you just have the SQL query, then we'll just do explain plan analysis. And we show all these insights that developers could then consider, review, and maybe some of them are indeed inefficiencies that they will have to fix before merging the PRs. So coming back to this part, this is tracking the result, the progress of that. Here you can see how many pull requests have with Unravel insights have been merged, or how many of them have request changes or resolved. And then each of these insights will be shown as a review comment. So we also show you how many comments are actually resolved, how many of them are ignored. And then for the realized savings, we show the 7-day realized savings that we have seen. And this realized savings is based on the resolved comments in the merged PRs. On the left, this is showing you the impact, like how many PRs have insights, how many queries with insights, etc. On the right, you see we show you the top 5 users with most merged PRs that address Unravel insights. It serves as an encouragement and motivation, and companies can also reward them, the most active users, trying to improve the performance and the cost of their workload. So with that, this concludes my demo of the health check. Let me know if you have questions. Thank you for your attention, and I'll give it back to Clinton. Thank you.
Thank you for that demo, Eric. Now let's take a few minutes to answer your questions about Unravel for Snowflake. Okay, here's a question that came in. What does Snowflake do to enable data observability? Well, Snowflake provides metrics, logs, traces, and recently announced Trail to help provide data observability and enable data observability for DevOps teams. And you can find a white paper in their docs titled Powering Observability with Snowflake. So definitely check that out. Snowflake recently launched a new cost management interface in Snowsight that provides account level consumption and spend. And Unravel integrates with Snowflake sources, and our purpose-built AI helps you quickly navigate all of this information in context so that you can quickly improve performance and reliability of your pipelines and queries. How can Snowflake customers securely share telemetry with Unravel? Okay, great question. So Unravel leverages the Snowflake Secure Data Share, also known as SnowShare. That option can be used for data transfer over shared connections outside of the virtual private cloud or VPC, or through private links. And this enables you to share telemetry directly with the Unravel Snowflake account in the same region. Great, and we'll try to get to some of these other questions if we didn't have a chance to during today's event. We'll follow up via email. Thank you so much for all the questions that were submitted, and we look forward to collaborating with you. So before we sign off, just want to remind you that you can get started today with a free account. Unravel Standard, this is free forever and provides you data observability for Snowflake. Just sign up at unraveldata.com/create-account, and then click on the Snowflake tab to create your Unravel for Snowflake account. Thanks again for joining us. And if you have additional questions, just pop those into the chat. We'll respond over email. Thank you so much.